Okay. Okay, so I think this is what I'm looking for. So it's structure, uh, focus before to focus after, structure, and then so STAB, A to B to S to T, something like that. Okay. So that's just as a reminder. I need to keep telling myself that so I am aware I don't screw it up in the because I screwed it up before, or I just want to memorize it. Okay, so we used the. I think this is just the view. Which one is this? This is the over operator, and we could use the set operator as well. So if we're gonna have a ship string, and we just want to set. So what comes first? B. So what we wanted to replace followed by the structure. So we want to replace payload something. Say I guess it's just set. No, sorry. Optics. Hey, Jappy. Oh. So we're going to say 10,000. So this would actually be ship int then. We can, well, let's actually use something else. String. Say 10,000. Set Serenity. Dot, oh, it's the other way. So it takes a structure. But we would need to do it on the payload. So I guess we would do Serenity. Payload? Something like we need to view the lens comes second. To view uh complete. Hmm. So a ship string seems to me like we want a lens here, but this is the structure, isn't it? Set. So the lens comes first. That's the trick. I'm looking at this wrong. I'm just trying to learn how to do this basically. So what I need to do, I see what I need to do now. I think I need to do this. So this is my lens, and then we're going to set a new value, and we want it to be uh this, and then we basically want this to be applied to some structure, and it can just be we can take say ship of A to this thing. variable not in scope. I did it the wrong way again. Yeah, so something like this. Okay. Ooh. Is that like the canonical way to write that? And is that ampersand a is that a lens operator? Not G. No, that's just yeah. Okay, it's just the plain old that one. I almost like this better because yes, there's parentheses, but it's clearer to me, I guess. The problem that I was having before is I was reading this and then I was like confused because I was like that can't be right. Where's the lens? Yeah, I'm setting this inside of the payload. And this basically this is just a function that would set any ship to this ship string basically. It's just to practice with the operator. And this was when we were messing around with last time. It's just like, can we convert a ship into a ship string by using over and show? Ooh. I mean, it's a profunctor, so it's co and con. Okay. Anyway, so that's set. And then I guess view just looks like maybe I should put this. Well, I'll just put it here. So it'd be like we're gonna take a ship A to A, and it will just be well, the lens comes second, structure comes first. So really, it's well, we can just use tuple sections, and then yeah. That I mean that's the right way. I'm trying to do it with the operator though, but it's just payload weight kilos, and then this. Wait, does this actually compile? It's interesting. It's kind of funny looking, but I guess it does compile. I would have guessed that I needed an extra set of parentheses. Oh no, it doesn't compile. Okay, it's complaining up there. What you need is another set of parentheses, I think. Because we need it to be a section. What if I... Oh, wait. It's the wrong thing. It's got to be... Wait, no. The lens comes second. I'm an idiot. It goes here. There we go. For sure. Yeah. It's the... I have it the other way. It's just view. And maybe I don't actually need this. Yeah, I do. I'm just trying to use the operator on purpose, even if this is awkward from a reader's standpoint. Just messing with the types, making sure I'm doing things right, using the operators, these sorts of things. That's the goal. Okay, so, yep. Yeah, this looks awkward, like from even my standpoint. I mean, it would even be better if we just wrote, like, it might be fine, it's even, but we're just playing, so I'm not concerned about it. Okay. So it's dot tilde set. Yeah. Oh, so the fixity rules make this okay. So is this fine? Nice. I don't even need these parentheses, I guess. I take it the dot has better precedence than those operators. Ah, nice. That's very convenient. You'd think I'd know that by now, but cool. Yeah, this won't work. Or, well, that line of code, but you know what I mean. Tend to use the $sign, but I wrote it in such a way where I don't need the $sign. That was kind of the point. Mm-hmm. And then take Serenity, and then regarding its payload cargo, set it to meta. Okay. Sure. Okay. For tricks, the fixity works out so that yeah, this pipeline thing, I need to experiment with this more because I tend not to write Haskell code this way. I tend to just write it the other way. But I think a lot of data scientists read like this, or they're doing their work like this, not the other way. Which I suppose isn't all that surprising. I should mention that I'm starting so early. Yeah, like if you were a data scientist, you would probably write something like this. That's much more common. When you're doing like pandas in Python, for example, it's always give me the structure, then start doing some sub selecting and then some applying, and you don't see it very often in Haskell code. So yeah, what I was gonna say is I'm streaming early today because the Minecraft Dungeons thing came out and it looks really fun. So I want, and my friends want to play in about 3 hours. So I started early so I can get my 3 hour stream done and then play with them. So if you're into like Diablo 2, for example, feel free to join the Discord and ask to play Minecraft Dungeons game. So I think it's really just Jappy hanging out, but if you're into that thing, I will play with you. Very fun. All right. Yeah, it's like I think it's like Diablo 2, Diablo 3, I don't know, something like that. But it looks fun either way. It looks pretty easy. Yeah, check it out. I mean, if it's something that you like. I mean, I played so much Diablo 2 in high school. The little dungeon crawlers are fun. And it's not very complicated, so you like doesn't require a lot of brain power to play. And that's really nice. All right. So we kind of did this. These are just some. This is interesting. Like being able to add to stuff. Let's see what that looks like. So this is gonna be just ship in stip. I wrote ship in. Then we could write like Serenity. Wonder if you would write this. Guess like this is how he's writing it. I mean, not really, but it avoids one amount of nesting. But even this is probably pretty readable. But maybe that's better. I don't know. We'll see what the formatter does. So we want to grab the payload, the weight. I'm trying to like not watch that and just think about it myself. And then we want to say percent tilde, right? Yeah. Percent tilde. And we could say something like plus, what do we got? 50,000, so we'll write 10,000. And I assume we can do this. Let's see what this does. Load. Yeah, over seems like a very powerful tool. Well, let's see how that gets formatted. Okay, it just puts it on one line. I'm actually not surprised by that. It's not that complicated. Okay, and then D should give us just 60K. And then again, you get to write these wonderful sections. So we're in Haskell, so great. Cool. So over, set, view. Yep, we're in chapter 5 already. Or are you saying that we're not very far? I'm not really sure. Let's see. So we had polymorphic optics, which is just showing us the difference between basically the lens prime and the lens types. Then lenses was just about lenses, and optics was sort of like preliminary information. So you learn things like what's the structure, the focus, sorts of things, actions, that kind of stuff. Essentially, yeah. I think there is, I mean, yeah, and then there's a composing lenses section, these sorts of things. Laws, and then like what you can do using like virtual fields, stuff like that. Data correction was kind of interesting. I mean, it's more than just that. Yeah, Chris goes at a pretty slow pace, but that's good. I mean, I feel like everything he's presented is important, and I've liked it so far. I'm a big fan of I'm a big fan of the book. The writing's really nice too. But again, I don't know that it was. I mean, it wasn't designed. Well, I don't know. I mean, I'd have to ask him what his target audience is, like how much experience they had in Haskell. Maybe he wrote that again at the beginning. I don't remember, but we're pretty far along our Haskell training. Yeah. Well, I think it's the one thing I like about the way he presents the book is like, yes, the lens laws are really powerful, but sometimes you want a lens that breaks the laws because it's more convenient while you're programming. The examples that he was using were basically data validation examples, which I thought were really useful. Like if you have a lens that says, give me this number, but it can't be negative, that violates the laws. Or set this number, but it can't be negative. It violates the laws, but it allows, usefulness to the programmer. I thought that was interesting. Okay. And also, we haven't actually done this book. Like it seems like we've been doing this book for a long time, but we really haven't. And so we're moving pretty quickly through this stuff. So like again, you can move as fast or as slow as you need to move, depending on. Yeah, but at this point, I don't know what traversals are, but we'll learn about them in 50 pages or so. Did they do hierarchy? I don't know what can you read this okay? I don't know if it's big enough, but I don't know where hierarchy stands in these topics. Maybe you would know, but I don't know what that word pertains to in lens. There is like a diagram. Oh, like of the different types of lenses, I take it. Or optics. I think that's what you would potentially. For anyone, since I'm just kind of waiting a little bit here, I'll read that here in a second. Just if you're you're interested in getting this books, you can get it here. So there's a link for the actual book. You can get a physical copy if you want. I think the link's on the link hub, but Chris had an issue with the physical book because of the way Lulu was doing some publishing. Like they basically deleted his book or something. But the code is also available if you just want to check out the code. Let's check this out here before I forget. Yeah, you gotta get books. I mean, this is like all my programming books up here, but they're the ones that I have in the house. I have probably another, I don't know, 30 at my office. So just depending on what I'm doing. Is this the hierarchy of lenses? Okay. Interesting. This is sort of like the most common operators. App-eq. So ISO, lens, prism, review. That means we haven't done traversal yet. We haven't done fold. I guess we've done setter, right? Okay. But I guess we've done setter, getter, and a little bit of lens. But not a ton, I guess. I mean, we've written lenses, so we have not done folds. Although this looks like a view, so that's interesting. So view is a type of fold? Is that what that means? Or there's other views, so there's a view here as well. So anyway. Okay. This is useful though. All right, so we've just kind of messed around with some of the operators here. So this is like applying a function. This one is setting something. This one is viewing something, and then we sort of put it all together by starting with a structure and then applying everything this way. That's kind of nice. And this time we were just using over as well. Restrictions on the view change. A fold view is weaker. Fully understand what weaker in quotes means in this case, but I'm sure I will learn about it, so I'm not terribly concerned. All right, so learning hieroglyphics. So I remember watching Jappy do some lens code on his stream, and it looked like hieroglyphics at that point because you just have so many different operators, but there's like a vocabulary for them. And once you understand the vocabulary, it seems like I would be able to read his code more efficiently without Hoogle. Like the only way I could read his code was having two screens, one with Hoogle open and one with his code, and then like go back and forth to try and figure out what he was doing. But you know, that's okay. We're gonna learn that. And the cool thing is I do see how useful this will be later on as well, not just reading Jappy's stream, which is useful. We're going to definitely do some data science with lenses. Would like to learn how to replace my pandas usage with lenses. I think that seems to be like or could be a very powerful thing to do. All right. So each operator can be broken up into smaller symbols. Each symbol is a single character, but sometimes it's two. You already know caret dot. We can break it down into two parts. The caret. Yeah, MyPy just doesn't do. I don't know how to use MyPy very well, so I'll start with that. But it doesn't seem like it's going to solve my problems. And what I really want is a static type checker at all times. So like if I'm just toying around with data, then you know I don't think anything's going to beat pandas. But when I'm ready to do something like here, I have this data pipeline I needed to apply to larger data sets. I would much prefer to use something that's statically typed. Yeah, everything behind the scenes in pandas is NumPy, and therefore MyPy does not play very well with that type of code. If somebody can prove that, I've asked this multiple times. If somebody can prove me wrong about that, I would be happy to be proven wrong. But I have not seen very good applications of MyPy using pandas and NumPy. Okay, so caret usually denotes that the action views or gets something. Getter, viewer, view, get. Dot typically. Yeah, I haven't used it a lot either, other than just saying like, oh, it exists, and I can read the tutorial and see some examples. But when it comes to like actually writing code using MyPy, I haven't got there. You should share them. Data science is very fun. I enjoy it anyway, but it's a lot of just wielding data, right? And that can be boring for a lot of people. I don't mind it that much. Okay, so typically used to represent the absence of any other modifiers. So I guess modifiers in this case means like changing it or modifying it somehow. Yeah. Histogram. Yeah, that's probably just built into some statistical package, so it should be pretty easy to apply things. Fit to Gaussian functions, check their overlap if they're Gaussian. They're probably not Gaussian, so I assume they're like long tail histograms would be my guess. Yeah. You just need to find some function to fit the histogram that's like representative, and then you can just check the overlap and things with that are, you know, closer together have higher overlap, something like that. There's probably like a technical term that you could look up. I don't know what it is offhand. Like I would just Google it until I found the thing I was looking for. So anyway, caret dot means get the focus without doing anything else, which is exactly what it does. Great. Now let's try percent tilde. We can break this down into percent means modify using a function. Okay. Tilde denotes that this action updates or sets something. So percent modify tilde view dot don't modify percent modify tilde update or set, something like this. So percent tilde is roughly setter or modifier which runs a function. Okay. It's not a perfect system, so it seems a bit awkward. That's because it is. The more operators you learn, the more sense it'll make. Sure. There are many more symbols to learn. Operators. All right, so add, subtract, or multiply is like setting. So this thing on the right means some kind of update, and the thing on the left means, oh, it just turns it into like a +5 section. That's cool. Divide the focus by a provided denominator. Okay, neat. Raise the numeric fractional or floating focus to the provided exponent. Note that caret yeah. So I mean the mass, once you know the name, like once you have the name of whatever you're trying to use, like whatever statistical method, then just look up the math behind it. And on like if you use pandas, SciPy, that kind of realm, they usually include the math directly in there, so you can just play with the math right in front of you. That's usually like how I do my work. Like I look at the analysis and I'm like, okay, does this math make sense for the kind of statistics I'm trying to do? Yes or no? And if the answer is yes, I just use it. If not, I modify it or find something that does what I need it to do. All right, so this one is starting with this structure, focus the first element and then raise it to the third power. So i.e. 2 to the third power is 8. This one is looking at the second element and dividing it by 2. And then this one's looking at the second element and adding 5. So again, this is kind of like alphabet soup. So if you aren't sure what's going on, please just ask. But this is kind of how this works. So it's like a structure followed by a lens, followed by some operator to modify the lens in this case. It doesn't have to be a modification, but that's what this one does. And some value in this case because we're adding 5. So it would have to be an integer in this case. If we put like a 5.0, it wouldn't work, for example. Okay, so we got a logical or and, wonderful. So or modify true. Yeah, well, this will always be true. Append the value onto the focus from the right. That's cool. How often do you use this, Jappy? Never. Oh, okay. Well, I thought it would be pretty useful. I mean, maybe not specifically with strings, but with other things. I guess I could. Those use type classes. Anything numerical will work on. Yeah, anything num or, well, depending on what you're using, right? This one requires some specific. Fractional and floating always behave weird to me. It's only because I don't use them enough. Never familiar with them. All right, so modifiers. There are a few more symbols which act like adverbs. They modify the behavior of an existing operator in some way. Let's just look at some examples. I like examples. It's going to complain that this can be a new type, but I don't really care. I mean, I'll probably change it, but I'll just let the compiler tell me. At some point, I really need to learn a bit about template Haskell. I think it will just do that. I guess it won't do that. I was expecting it to, but okay. Hello? Hello? I guess it wants to format like this, but it shouldn't because I have it formatted like this up there. I don't know what it's doing. Formatters in Haskell are weird to me. Okay, anyway. So let's just, now that we have that in here, let's just open up our REPL. Well, we should write it in here, otherwise it's going to be confusing later. So we're on E. So what is this doing? We have a, interesting, get the altered focus in addition to modifying it. So this is going to return a int and a thermometer int, I guess. So we're going to say, start with the structure, and then we're going to apply the temperature lens, and we're going to add a number to it, 15. So that's why we get duh, sorry, doesn't take an A. All right, so this thing, we understand what this part means. So the plus tilde means like add 15 to this value in this case because our temperature focus is there. And then this thing means save both the modified. Oh, okay, no, it saves both modification. All right, so it added 15, blah, returning the altered structure, but also returned the result in the tuple. All right. Yeah, I guess I could see how that was useful, potentially. I don't do a lot of deeply nested stuff yet, so hard to say. Yeah. So this one takes the modified value and sticks it at the front of the tuple, and then this one takes so the result. Let me put this down here. Result would be 35 thermometer 35, right? And then this one would be 20. So it's like keep the previous result. Well, sorry, it's probably you probably think of it like, yeah, copy it. Yeah, so this one takes out the previous result, and this one takes out the result. So that's kind of interesting looking. So double less than returns the pre-action focus, and the single less than returns the post-action focus. I think that's the right term. Yeah, maybe. I mean, I can't think of an obvious use case yet. I mean, again, one this simple is very, very easy. But if you had a very deeply nested structure, you don't want to go get it later. No, I have not read the Arrow paper yet, but that would be a good one to read. Okay, so when to use operators versus named actions. Oh, like this style. Okay. We used arrows before when we did. What is that database library? There's one that you. But it wasn't fully clear to me at that time what the arrows were doing. So I should have. I didn't spend the time to look at that. I probably should have. Yeah, this is kind of what we wrote before. Yeah, there's like an extra thing that you get on top, right? I don't know. I kind of like both of these. But this is like gatekeeping, right? Although, I mean, this is still gatekeepy, right? If you don't know what over is, no one understands them. Yeah. Yeah, that's kind of funny that talk about gate. I didn't even notice that. All right, so my favorite part about doing this is always doing the exercises. So let's do those. Exercises. Towards. Okay, is the gate opener closed? I don't know what oil temp refers to in this particular case, but sure. Okay. Assume we're gonna get some like deeply nested thing. Army. Knigets. I really want to watch Python now. Well, and the Holy. Let's see. Built-in syntax. That's cool. So, Chexer, do you have like a particular case that you think arrows is like killer for that would make it obvious? For, oh, well, okay. It would make it obvious for why that's a huge deal, or arrows are cool to learn or something. No, okay, fair enough. The only time I've seen it is that Postgres database. Did I say the name earlier? Because I seem to have forgotten it again. I can't. Wait, what is this? Here, Postgres, Opali. So there's arrow syntax in Opali. And so we learned just enough about it to use it. All right, so we got we got archers and we need kingdom. King. Yeah, you're I don't really have an answer for that. Me. Ergami. Gate. If I could spell. Okay. And lock. I wonder if this is actually a kingdom. I don't recognize the name offhand, but also I'm not like into that kind of stuff. Oh, you know what? I think that if I just press comma, I gotta get used to that. If I just, instead of trying to like tab or type or whatever, I just press comma, it aligns correctly. Always mess that up. And I'm also messing this up. Wonder if I pressed comma there if it would work as well. Probably would have. Gate. They have their doors open. Well, temp is 10. Sure. Oh, and this needs to be underscore. Okay. So basically using the following types and lenses infix operators the autocomplete plugin is basically coc.nvim attached to Haskell IDE. So if you want to check out, oh no, it's just editor. I have my editor on the whole thing, yeah. But it's pretty powerful. I'm pretty happy with it. You also get things like if I, why is this like this? You get, you know, types, so it tells you that knight is army to int, for example. So you know what the constructors are and sorts of things. You can look at more complicated examples like this one, for example. It will tell you what the result type is, for example. And having this stuff in here is really powerful. Because as you know, IDE is hard. Okay, so 60G. Final states in book. Pages 73. Through 74. We won't dwell. All right, so what are we trying to do? We want to change. I guess we start from top to bottom. So goal A. We're gonna start with Duloc. Unsure of pronunciation. Right, I actually wanted to look that up. Duloc Castle. Is this from? I mean, I don't know if this is actually where it is, but that's hilarious if that was the motivation. It's where Lord Farquaad is from. I wouldn't have recognized that offhand, but anyway. All right, so first things first, we need to try and see if we can use the append function. So we're gonna say, give me the name, and then we're gonna use this function to append a perfect place. Oh, but I need this as well, I think. Isn't it like that? Well, maybe it's this. Oh, and I don't have my lenses. Now I should have lenses, and I think that should work. So this one, so if you recognize this operator, it's basically the mapend operator. I wonder if there's also, in this particular case, a plus plus. It doesn't look like it, so it looks like we gotta use mapend, which is fine. And then we need to add. So we're gonna take army dot archers, nope, dot knights, and we're going to plus 28. And then we're going to gate.open I guess we didn't get, I guess we just use over not. I don't know if there's a cleaner way to do this. Jabby, you're welcome to chime in at any point. Goal A. Okay, Duloc perfect place. Archers 22, 42. Oh, that's fine. Don't worry about it. I mean, I prefer doing it my way anyway, and then seeing what we could clean up. And it seems to me like there's probably not a better way to do this one, just because there's probably not like a not lens. I don't think that that would be hard to write as a binary operator. So it probably makes more sense to do over not. And then we kind of saw this one before, so that's fine. This one's pretty easy. We could also have used if, um, you know, I was dumb, I could just do set 42. Dumb, that's to say that. That's really rude, actually. You know, if I didn't feel like doing plus, which I was just trying this out, we could also have used the set operator to change that to directly to 42 instead of using plus 28. I don't know if there's any reason to do that from a performance standpoint or something. It's pretty easy. Okay, that wasn't too bad. And then, yeah, I mean, if anyone wants to make any suggestions, I'm more than willing to give them a shot. So, oh, that's what you mean by that. Okay. Yeah, I mean, we're literally adding 28 to an integer. It can't be that. Can't be that slow, I would guess. Goal B. So kingdom. We're gonna do the same thing, basically. A Yoneda. I mean, I don't know exactly how it works, but I think the idea is you if you have a functor, you can get a monad from Yoneda. I think that's the goal, but don't quote me on that. It's probably more complicated than that. I don't remember. I should look that up again. But at one point I kind of knew what they did. But this is basically the same kind of thing. So it's just like Einstein. It's very important. Yeah, I read the Monad book, which talks about Yoneda. I read the Haskell programming from first principles, which mentions Yoneda, but I've not spent a lot of time with it, so there's probably a better way to do that. Okay, so then army dot archers, we'll use set this time, which is percent this, I think. No, that's over. So it's just dot this. And then this becomes 17. Knights becomes 26. And we can gate dot oil temp and times it by 10. I think that's probably it. Goal B. The Lockenstein. 17, 26, true, 100. Great. Okay. Goal C. We're gonna get string kingdom. Okay, so first things first is we need to do this change to create this. So we're gonna say Nope, that's the we want this one, I think. So it's gonna be, I don't know, rs. I don't want let. Okay, so now we have s, and we just want to take name of the talking donkeys, and what do we have? 2214. That stays the same, and we want to divide oil temp by 2. So gate dot oil temp, the divide 2. We can say, oh, right. We actually do want let in this case. Oh, I see. So it's actually Duloc at name this. There you go. So right, we have the structure, but we need a lens. So the lens that we're trying to mess with is name. Now, what does this thing say? So first, take this side. So just the sort of right side. Ignore the first less than. That means append or mappend the string on the right to the focus from the lens. So it would just take Duloc and add colon home. Then this first one means take the result of that and stick it in the beginning of this tuple. So it's R here is just some return string, and S is the structure after the post action. It's the structure after. It's not the structure after. It's the focus after the post action and the structure after the post action. So that's what this is. And then what we do is we apply the other changes that are necessary. So the of the talking donkeys is necessary, and then we need to divide oil temp by 2. So I think this is right. Let's see. C. Oh, right. Refresh. Goal C. Duloc home. Wonderful. Home of the talking donkeys. 2214. True. 5. Nice. So that's not very hard. I can see already how easy it is to combine, like make these if you know what they mean. So, but you need to know what they mean. If you don't know what they mean, it would be very hard to read this code. We could use it in, there are words, although I don't know that there's an equivalent to this in words. Hmm? It doesn't look like it. Yeah, I mean, even in here, they're not using words for the definitions, so it is what it is. This is an over operator with the saving the result. So over append m to the right, then save the result. That's your line. It's pretty readable once you get that, but It is not readable before then. Okay. That was fun. 2. Enter the appropriate operator in the undefined slot. So fill in the blank. What are we on? E, F, G. So the result is going to be bool string G equals false customs. Did I spell it right? No, 1P. Whole. Can you do whole like that? I've never tried this before. Yeah, look at that. All right, so the result. So this means logical OR. And all we want to do is view. So I think it's just but that right. So we need set. So this one. The other one. That one. What do we need? I'm going to reach in to the first one. That's over. That's not going to do it. Let's look at this type again, I guess. We want the structure to remain the same after. Struct. We use view. The result is this. So I thought it was going to be set, but I don't think so. We'll look at some operators. I'm clearly. Oh. It's supposed to be and. Okay. Why? Right, so what's this right side do? Let's look at this. These don't really mean it. Let's think about it. So this is saying, given this lens, take its logical and with logical or with true. This is our structure. I guess this makes sense. It's very similar to what we were doing before, but our lens is _1 and not some named one. Just apparently stupid. Okay. Anyway. Or I didn't see it, obviously. Oh, make each code example consistent. Okay, so that was one of them. So fill in the thanks. Each. So we're gonna get int back equals 2. So the structure is 2. We're gonna take id undefined 3. Remember that id is a lens which focuses the full structure. So we need to multiply. So this is going to be id times tilde. And that should give me, sorry, I believe, h. While we're at it, we can do g and see that that's right. Again, I. Oh, so cool string float I guess. True. Dudley. 55. The worst. $15. Making me do math. Hey, new maid, what's going on? Thank you for the bits. Wait, no, these are cheer. See. Thank you. Hello. Don't give me 500 bits. That's okay. They're gonna go on the the YouTube. I know that some people don't always like that. So sorry. Would prefer to see it live, but no. Okay. Just really busy. Or just not in the mood, basically. Yeah. So this one is clearly just a set. So that's just this one. Or is it dot tilde? I always get it backwards. Dot tilde, I believe. Thank you very much. I appreciate that. Very much do. This one is clearly append. All right, and then what's this one? What's 55 divided by 15? No. Minus 15, I guess. Divided by 2. Okay. So this one's minus. That's a hilarious looking operator. Really impossible to. And then this one's divided. And then this one is just over. I think. Need upper, which comes care. Okay. So basically the idea here is, if it's not clear, is we're just filling in these blanks with the right stuff. So we just had to figure out what was being done. I think this one's the most obvious. This is just like a setting operation, because right, false is the only thing that changes, and we don't mess with 1 1 other than this one. So we don't need to like do anything special. We could also have logical anded it with false, something like that. That would have been fine, but we clearly can just set it and it's fine. So this one is mapped to upper, will just give us the upper. And then I just figured out what this was, minus 15 divided by 2, fine. And then this is just an append, which we've done a bunch. Easy. Easy. All right, 3. Name a lens that takes only 2 arguments. Guess you? Right. 1, 2. Name a lens. It's operator. So view, yeah. What's the type signature? Okay. Well, we can just do this. Ooh, neck. Yikes. Okay, so T. All right, so we looked at this before. So we have like functor F, A to F, B, S to F, T. So the idea is we're going to modify something. So we need like a lens, clearly. All right, this is the over function. We need an A to B, and we need an S. Something like this, I guess. Do. Let's see if we got anything wrong. So we take the lens, we take the function to modify, and we need a structure to apply it to. Okay, well, it's a specific type. It's a setter, but that's fine. Still a lens. A to B, S to T. Yeah, cool. I'm writing this to just remember, like, all of these are kind of this shape. And it's a good thing to just keep writing this over and over again, I feel like. Okay, so there we go. I guess that's everything, and we can double check our work. Well, we kind of already did double check our work. We just need to check these ones. Oh, and also let's see how he implements the goals and see if there's anything to be learned from that. So one thing that's nice about this is you can quickly jump to the answers, but my particular viewer kind of annoys me. Oh, without. Missed this. Did I use? I guess I did use over once, but we could easily have switched this to. So not is the same as logical and with true, right? No. If you get false, you need true. You false and false. Um, okay, so that's not going to flip a false. You could do or true, but then you need to flip true, which won't do it. So you can't do it with a single operator. How do we do it without or? I also have no idea what this one does. Oh, it's just dot tilde. I see. Don't use modifier set. Okay, so we didn't do that here. We didn't do that here. Okay, let's go look in here, I guess, and look for. I don't really know if there. Maybe there's a not. I don't know. I don't know. I'm not exactly sure how to do it without over. So let's just look at the answer. Oh, okay, it doesn't need to logically flip. Right. It just needs to change it. So, sorry, I was thinking I need the equivalent of not. That's not actually what I need to do. I just need to flip it. So it was true, and I need to flip it to false. That's it. So actually, yes, I can 100% do that without um without why am I losing my train of thought? Without not. There we go. So that's fine. So for this one, I assume he just replaces these with, yeah, some number here, which is totally fine. No, he squares the oil temperature. I just multiply by 10, fine. And he's kind of doing this in reverse order from how I'm doing it, but that's totally fine as well. Let's see if there's anything interesting going on here. Okay, so instead of using this let, he just uses an additional lens to go over the second one, which is fine as well, obviously. So this makes perfect sense. Okay. Yep. That one times up. Yeah, yeah, it would probably read a little nicer. So like this, let's just quickly do it. So I'm gonna try and not look at this again. I mean, obviously I've already seen the answer, so. We want to start the lock. Name. And it's basically just this. Oh. Okay, those are exactly the same. Okay, sweet. So done there. Sweet. Okay, close this because we're gonna start a new chapter. All right, so introduction to folds. And actually, before I forget, we did get 2 new followers recently. We got Anton. I don't think I announced. I feel like I announced Shady, Endless, and Karng, but I didn't announce Anton or Bitnot. So thanks to those 2 folks. If you're hanging out, feel free to say hello. I'm always here to answer questions. Okay, so we're gonna learn about the fold optic. Folds are like queries. You can select subsets of data from all over your structure and collect only the pieces which you're interested in, filtering out the stuff you don't care about. We can describe folds in terms of something you know. Lenses must focus one thing. Folds can focus many things. That's kind of cool. Lenses can get and set. Folds can only get. We can't set using fold. We can forget about using all those fancy setting actions. Folds don't even have any laws. Interesting. I suppose because there's no set component, you do. All right. um, Fritz. All right. So let's put this in here and see what happens. Bunner. Powder. Key. Presume they're gonna get us the gunpowder. Capitaine. Eight. Data. Crew. Member. Talents. List O string. Board. Lenses. Member. It makes sense to make a roll lens. I don't think it does. Presume not. Did we do that before? How would you get? What would you set? You'd only get one thing every time, I suppose. Or set one thing every time. Anyway. Uh-oh. We may have to change our version of GHC. And then up here we need to say import data set as S probably. Crew member Grumpy Chappy can be gunner. Chappy, do you juggle? Long John. Who made? Anyone else want to be in here? I think only 2 people have talked so far, so. Salty. Part of the codes. Cootery. Anyone else? We can bring Lumi in here. He'll appreciate it. With no talents. Poor Lumi. Alright. Something is complaining. Yeah, I mean, he's probably a busy dude. What's the problem here? We really don't know. Oh, right. Qualified. We need containers. Reading specs, probably. That's funny. The amount of stuff that guy knows is pretty impressive. We probably have to restart this though. And we'll just leave the REPL open down here. And I need to update stream title 6 folds. Okay, cool. All right. First things first, we need to find out which roles we've successfully filled. All right, I can see how that would be considered like a folding operation in the context we've learned thus far. At this point, we don't care who filled which role. We just want a set of the filled crew roles from our roster. This task involves querying small pieces of information from many places across our structure. My nose is driving me nuts today. My allergies are going crazy today. Apologize, I'm like messing with my think about where we're actually going. Just everything. I have cats in the house, the outside. As it gets hot, it's just everything. Yeah, that's true too. I mean, I'd love to do it, but would I remember it? I don't think I would. All right, so we're gonna make a fold. We want a set of crew members, and we want this says that the roster roles I'm guessing this is our structure. This is our focus, but there's more than one of them. Kind of surprised that this isn't a like a list or something. Kind of. I mean, yeah, like a specification is very dry. I don't think I could read a specification ever, as much as I would want. It would be very difficult. It says that roster roles fold can focus 0 or more roles. I mean, ideally, I would like to do that just so I have an idea of spec work. And maybe it would be a good idea just in general as like a this is what a specification looks like. I've always told myself I'd like to, or not HTTP, like the entirety of it, some of it. Yeah, so okay, so my intuition is correct. I'm surprised that it wasn't list of role. All folds focus 0 or more focuses, so it would be redundant to note that with using a list. So how do we build this? Okay, so first focus each individual crew member in the roster, then focus the role within each of those crew members, run some action to collect all of these focuses from the roster. So get all the crew members, get all the roles. Is that the H? Do. Okay, so let's start. Work our way down. Great. So that's our structure. This is our 0 or more focus. Should type check. This operation is pretty simple conceptually. Given a set of things, we want to focus on each thing. Really, this is a common enough task. It's already a helper for us. Is folded. So I guess we just describe A probably as a lens. Okay, we don't even have to do that. It's literally just called folded. Neat. Easy. Yep, sure. Alright, so lenses must focus, whereas folds can focus many. Similarly, view, caret dot, always retrieves thing, but to list of view or caret dot retrieves 0 or more values in a list. actually use view on fold, but it doesn't do quite what you do. So we can do like, well, let's just do A going to be a list of crew member. A equals roster interesting. Okay. If we try using view, we'll get. Oh, okay. So I don't know. Traversals are next, so we can compare them next chapter. Unfortunately, I don't have the tools to compare them now. Oh, you think it's the same? Okay. Traverse. Is it traversed? It's probably traversed id or something. Traversal. Not there. In to list of. Oh, here. Sorry, I misunderstood what you were saying. Okay, so folded is slightly more general in data structures without a traversable constraint. Useful. The structure is also traversable, then they're the same. Also traversable, same. It's folded on sets, but you can't use traversed on sets. Useful. And Zefchip, you're Chris, right? I just realized I don't remember your Twitch name. Okay, right. So Jappy, that's the author of the book, so you can say hello. The lens master, if you will. Jappy is also pretty good at lenses. Yeah, big. Okay, so we've got to list of. All right, so that's just the function, which is lens master. Yeah, we're gonna become a lens master. We're gonna collect. We're gonna pretend that these are Pokemon, and we're gonna try and collect them all to our brain. Not gonna happen. Chris, you'll be proud of me. I was able to do this one. You said it seemed like it was hard, but we did do it. So pretty cool. Not terribly hard anyway. Like I like the way that you continually say like decompose problems, right? Like that's basically what you need to do every time. It wasn't really even that hard. Once you realize you need this operator, well, I guess you don't need it. There's probably other ways you can do it. Once you realize you need that operator, then it's not so hard. And what that operator means, right? That's the key. And then we did goof up one. Well, we didn't goof it up, but we didn't do the hard mode version because I missed it. And then I also got stuck because I was using something like lens over not. And then I was like, oh, how do I not use over in this case? But you didn't actually tell us to, you didn't say to flip it, you just said to change it. So we didn't really need not. We could have I could have just done something like logical and with false, which I think you put in the answer. So I realized after I looked at the answer why you don't need over in that case. Okay, anyway. Uh, so, right, this is the same thing. This A is this. Mm-hmm. Okay. Remember that it works on anything that implements the foldable type class. Just he is foldable. Okay. Nothing would give you empty list. Sure. Identity certainly implements foldable. Right. If you try and fold a tuple, it would be like messing with the second object. It's only foldable here. Is there something like bifoldable? Probably, but I've never seen that before. Foldable? There is a bifoldable, yeah. So it must be, well, in this particular case, this is bifoldable because a string is foldable. That's cool. Is there a bifoldable operator? That would be cool. Or, well, this is like to list of. So I guess you need to modify this to bifolded or something. Wonder if that exists. Curious. Oh. Oh, both and each. Okay, so that makes sense. We would just do both folded, and then we would. Well, let's just do it because I want to. And now I'm very curious. Curious like a cat. My friends call me Whiskers. You know what that's from? I don't know if anyone would know what that is. So we would do what? So let's start with both import control lens. Both. Okay. So function a container of two things. So this must be this, I guess. Okay, so probably both folded but do I do it like this? That's the question. I think it's gonna be like that. No, because that's like an interesting I'm trying to think out loud. I see you sending me messages trying to help. At least I assume you're trying to help, but I kind of want to see if I can figure this out. Although maybe it's supposed to be each. I'm just gonna. Yeah, I mean sometimes you can just do interesting stuff, right? But this is kind of an interesting like almost a zipping operation. But what's very strange is how it finishes. Oh, it's taking each one of these and combining it with everything else. Yeah, that's cool. Yeah, yep, Cartesian product, as it turns out. Um, so I think you want what's does this produce even anything? No. Oh, it does. I think it does. And I'm doing this. Well, okay. So we want this then. And we want to say maybe I'm literally guessing. Um, so that means who list of. That's interesting. That's what I did, right? Yeah. Although if I put it no, because the composition has higher precedence. Is this what I wanted? What was I expecting? I think I was expecting this. Right? The extra folded. Is this extra? It. I think that's what I want either. Maybe I wanted each. I don't know what I want. So I think what I was looking for was this. I think. Like this is what I was thinking about. Where's the example? Right here. Right? So if this gives me the foldable instance over this, why can't I highlight this? Hello. Yeah. And I get this. I wanted to use the sort of by foldable instance to make well, it might not be a fold, but that's kind of fine. I'm just thinking out loud. Okay, so basically so I see two list of id and then also over appending an empty list. So basically we're not cheating. We're ruining the whole point of folds, which seems that's fine. It I'm removing the idea of fold in general. Okay. Anyway, these two are kind of interesting. This result and this result, and these are folds. But this would certainly not work if these weren't the same type. It should fail. It should fail to type check. Yeah. So, but it does work in this particular case. I guess that's what I was thinking of, is like in a case where these were not the same and you wanted to fold both of them, right? Like I want to fold over 0 and over gold. Does that make sense? Maybe that it. Okay. Anyway, um, decide. Okay. Do you see what I mean though? That's still a fold, right? Takes a fold for each half. Yeah, that's what I was thinking of. Okay. Anyway, we went on a tangent there, but that was kind of interesting. Holding a map, focus only the values, not the keys. Okay, that must just be because of the implementation of map. It's fine. Yeah, I kind of understand this. Let's go back up here. So now that we're able to focus the crew members, we want to go a step further and focus the roles. So I guess that means we're gonna say roster role this gets us the crew members. And then maybe we just I'm just guessing, by the way. No worries, Jebby. Catch you later. Thanks for hanging out. I'm just writing stuff, by the way. Just seeing if anything type checked and then just think about it. But it doesn't, so that's fine. We'll keep reading. Yeah. Oh. Okay. So how do we combine them? Probably map. Oh, I got excited. Didn't work. But that's not really a map, right? Because it's not really returning a list of roles. Well, oh, and also, right. This is returning a list of crew members, which is not really what I'm trying to do here. This fold is slightly different than this. So, okay. To list of. You see that the roll lens focuses Jerry's roll. How does that lens know how to fold? Sure. You drop in a lens anywhere you need a fold. Well, let's just write this one as well. So well, I guess we don't need to write anything. Hmm. Okay, I need to stop just playing and restart reading. Sorry. Um, yeah, so this is what I was expecting, something like this. So if I did this dot roll, that would give me a list of rolls. That's what I was expecting. Um, this part I don't quite understand what we're going to do. So composing folds to dive into our structure to select the pieces we care about. Is it just folded dot roll? Okay, that makes sense because we're not actually like this. This feels like performing the fold, or well, I guess it's this whole thing because it's to list of. But this folded has to do with the set, and this roll has to do with the crew member. Okay, I think I see this. Um, okay. Both bitraversal, bitraversable. Every traversal is also a valid fold. We sort of talked about that earlier. Okay. Different. Yeah, we kind of messed with that before. Ethers. Are the same. All right. So um we kind of gain this intuition by using it, which is cool. I'm glad that I was messing around with something that you show. Although you did say you were going to show me it, so that's not surprising. Oh, that's cool. Yep, and then this will get the ladder too, right? Because this would be like tri-traversable. I don't know if that's actually a thing, but ah, okay. That's what an each is. So for a tuple, each and both do exactly the same thing. It's only for cases where you'd have like something deeper, deeply nested, where you would need each, I guess. Yep. Okay, that sort of makes sense. That's interesting that it flips the type. Mm-hmm. Neat. Let's see if we can figure out these exercises. Mm-hmm. 3 sirens. I always want to know where these references come from. Pogo Pogo. You got a lot of great references in. There's a Lord Farquaad reference earlier. At least I think it was. Really enjoyable. Alright, so you've not passed further than the list as far as I can tell. But I think this returns the same thing. I think this will return this. Alright, so now you've gone further, which means I think we end up with Sirens, Kraken, Pogo Pogo. This feels almost like FMAP. And now the real question is does this really behave like FMAP? Does it just return the list? I'm gonna guess that we continue down the way and we get this. But to be fair, it's a guess. That's essentially identity in this case. Okay, moment of truth. Nice. Okay. I said it feels like FMAP, but that's not. I guess it is kind of what I. Well, it's a fold. That keeps saying FMAP, but it can't be FMAP because FMAP is structure preserving. It's a fold where you're sort of reaching into the various levels of nestedness. Oh, we're not done. Okay. We'll guess this again. Hmm? Well, I guess it's not really a guess. I think I know. Okay, so this one. So we have a list of lists. You're gonna fold both of them. So this is equivalent, I think, to this. We'll check, but I think so. And then that should be, I think, them in a single list. So the first folded returns this essentially identity in this case. The second one will reach in. I think we get that. Let's see if this works as well. Yeah. And is this exactly the same as this? My guess is yes. Again, I keep saying guess, but I don't think it's really a guess. It's intuition at this point. Okay, this one's a little more complicated. Doo-doo-doo-doo. Probably don't this. We can do this folded or qualified data. Oh, we have to guess what this does first. So we know that folded will reach into the values, not the keys. And then we fold again, which means probably get captain first mate. He thinks. Oh well, again, there's yeah, that was just a typo. That wasn't really a mistake. Okay, so put this in here. So this time we should get hello. It's I think. Shield. So serious. So this one will just be these concatenated together, I think. Although we don't fold them. Don't remember the exact behavior here. That's just identity, but that's a single string. So I think that this just returns itself. I don't think it does anything unless you fold it. Let's see if I'm right. In a list. Okay, so if we did folded here, then we would get them together. Okay, right. That's to list of, not to tuple of. Makes sense. Okay. Import text t package. Whoops. Oh. Strings. Okay. Each. That's gonna be list. That would be my guess. Close this. Good. Oh, import control. Oh. Oh, right. We need to list. So we have the list of characters, which is a string. So technically I was right, but yeah, those are functionally equivalent. also known as Y. So okay, neat. Write out specialized. Combinator. Okay, so folded and let's see how we write this. Where was I? A. So B. Really kind of like just so folded is a fold A? Is that right? Oh no. I messed up looking at the type of this. Oh, F2. I can kind of see the traversable shape now. Did you give me like a simpler version of this? I just don't remember. That's what I thought. So let's pretend that we want to write something like this. So what is it folded here? It's gonna fold a list of int car to focus on car. One is gonna be int, well, fold int car. Yes. And the actual type is much more complicated than that, but I presume that this is what you're looking for. Something like, we'll have to see when we get to it, but that's what I think you're looking for. Otherwise, it ends up pretty complicated. So we want folded to and okay. So we got this structure. We're gonna save this into C. Okay. So 2 in this case is going to be a fold the structure is S set string. Yes. And we, oh, no, that's incorrect. It's a bool set string set folded takes the S set string to string. This takes the gets you back list of string. So let's see if that's actually Capybara Toast. First of all, freaking awesome name. Capybaras are awesome. And thank you so much for that. I just noticed it, but it was 23 minutes ago. I hope you're still hanging around. I'm kind of focused right now, as you can see. Focused. That was a complete accident, but it turns out to be kind of fun. Ooh, wait. Oh, I did B. I want C. Sorry. Sorry. Story. 2, 3. Well, 1, 3. Wait, what? Oh, right. Set is probably unordered. Well, it has to be ordered. It's in a list. Or this is the behavior of folded on a set. As in, foldable for set must just pick out the elements in some order. Let's just look at set. And we want foldable. Right, these are ordered, so it must source code. I see. Okay, that makes sense. If they're ordered, then it's simple. It's relatively simple, I suppose, because you just put them together based on their ordering. Okay. And I guess sets are ordered in Python as well, but maybe not. I don't actually know what the implementation dictates. I'd have to look. All right. Anyway, I think I'm doing this right. That could be. Yeah. That could be. That very well could be. What was I doing? Oh, right. I need to enter this information. Very distracted today. We did this one. So now we need to look at folded, and to list of the okay, let's put this at the top. I feel like I'm looking down and my neck is bothering me. All right. Import qualify. probably can just do this to make it happy, and that's because we have overloaded strings on at the moment. I don't know that that is actually a problem if we turn that off, but anyway, we'll just give it a type hint there that has to be a string. It seems happy. All right, so the first folded. All right, so we got a map. So we're doing values again, probably. So this is going to be, well, not probably. This is going to be a fold of m map string, assuming that it interprets these as strings. I'm not even entirely sure, but it doesn't really matter. And we're going to focus on string. Don't need a. The second fold is going to be that one feels awkward. Because it's like a list, but it's really focusing on all the values, right? Like simultaneously. Or I'm sorry, the first folded focuses on all of the strings. But I'm not entirely sure what I put here because it feels like it should be like a list of string. Anyway, this is going to take a m string and produce a, ooh, right, this feels more correct, and return a string. Huh? Maybe? Yeah, I think this feels like the right signature if I had to guess. Okay, neat. Yeah, because we're gonna focus on the individual elements and then basically fold them back together. I think. Okay, we'll see what you say. Maybe I'm thinking about it incorrect. What time is it? About? Okay, 8:40. Good. We still got time. How much more is left of this chapter? Quite a bit, actually. Yeah, we're not going to finish the chapter today. I'm going to go for about 15 more. We'll look for somebody to raid. Fill in blanks with appropriate bold results. Okay. E. Yeah. Bolded, I think. We're going to have to do some specifying there. again because of overloaded strings. Now this guess maybe we just don't need the folded. Okay. Right. To list of. Repeat it to yourself 100 times. You'll get it. All right. See you, Chris. Thanks for stopping by. I'm having fun with your book. I'll keep saying that. I enjoy the writing, and I enjoy playing around. So this is the same thing. No, it's not. It's folded. That one. It's my pleasure. I hope people get something from it. Dark sad. I don't want anyone to be dark sad. That's for sure. Okay, so we need to folded dot folded. I think this will work because we want dark sad, not list dark sad. I think that's what we want. No, we need another one. One more. And we need to basically say, hey, look, you're a string. You're allowed to do that. Reload. I don't know. H. Yeah. Okay. Bond. You just copy this. And this is just each. Okay. Actually, with that note, I think I'm gonna stop because it just I don't want to start a new section and get partway through it. So I think we'll stop here, and actually, let's double check our answers first because. So we'll go here. That'll give us a little time. Okay, so piece sizes folded. Right, we're supposed to guess what this does. We already checked all of them, so we don't need to look at this. Write out these specialized types. So folded is fold int car list int car int. Yep. So anyway, I think once I see this, it's pretty easy. The last one is the one that we had trouble with, though. And we figured it out. So fold string car makes sense. Oh, right. Technically, this is wrong. Or not this is wrong. Sorry, mine is wrong. I was thinking that what I actually wrote was the start and end type, but I didn't write the fold. So, you know, there is a whole there's a folding structure here that we also need. So we got to fix that. So this would be fold bool set set string But to list of. But that's not the right one. Where's to list of? Da-da-da. And then to folded, but not to list of. Okay, that's fine. Anyway, then this one should be fold m map string. Oh, I need the actual focus, which is car. Okay. I think that's right. All right. And then we'll just double check. Well, we already double checked these as well, right? It's pretty trivial to just check them in the REPL. There we go. All right. So